Hi, this is a tutorial series on InMotion, which is a motion and dynamic simulation add-in for Autodesk Inventor. In this tutorial, we are going to consider rotary spring being acted on a revolute joint, which can also be extended to a cylindrical joint. In our example, we are interested in a revolute joint that is formed by this double pendulum with a pendulum base. This is also known as torsion pendulum. And we have enabled the visibility of insert one markers by right clicking on say insert one here and say we have an option of show marker. Similarly, we go to insert one in the second part and say show marker. So the visibility of marker is to give us an idea as to what is the angle between the joint. So the angle between this joint is say around 45 degree, that is between the red axis. We make sure that gravity is set to 0. Then to add a rotary spring, we right click on insert, we go to define rotary spring. For this particular setup, we have got good result for 0.001 Newton meter per radians, and initial angle we set it as 0, and we go to simulation player and we make a simulation from say 0 to 5 seconds with this interval and start simulation. The simulation takes place and we get the playback deck. Let's increase the speed. We go start. Now as you can see, the angle between the red axis is decreasing. It has come to 0 and it keeps on increasing in the negative direction. It goes to another extent and again comes back to 0 and goes to initial value. This means that earlier it was in compression state, this is in compression state. When it comes to 0, this is in neutral state, and when it passes and it goes to tension state. Okay, and we can imagine the rotary spring to be in a circular fashion at this insert joint. And let's see by changing the angle between the initial red axis. So we go to simulation player and again we'll try to simulate, and now we get playback deck. We again start the simulation. Now we can see it was from 90 to 0 and again it goes to minus 90. This is in tension, then it comes back, it goes to its natural position, and then it goes back to 0. Okay, this is how torsion spring works. Yeah, thank you.